Hi everyone, it is Sridhar at E-shikshana. In this video, we'll discuss on signal conditioning. In signal conditioning, we'll see the definition of signal conditioning, general measurement system, functions of signal conditioning equipment, amplification, and types of amplifiers. First, we'll define the signal conditioning. The signal conditioning is the manipulation of an analog signal in such a way that it meets the requirement of the next stages for further processing. Or more precisely, with respect to sensors and transducers, we can define a signal conditioning as the process of modifying the output signals from the transducer into usable and satisfactory signal using amplification, attenuation, linearization, nonlinearization, or multiplication by another function. Next, we'll discuss on general measurement system. It consists of input, a physical quantity to be measured, a transducer which measures the physical quantity and sends the output to a signal conditioning equipment or a signal conditioner. The output of the signal conditioner is presented as a output out to a display device or a recorder. The first stage detects the measurand is termed as detector or a transducer stage. In most of the cases, the quantity is detected and is transducted, converting into an electrical form. The output from the first stage needs certain modifications before it is used for a presentation. The necessary modification is carried out in an intermediate stage, commonly called signal conditioning stage. The last stage of the measurement system may consist of indicating, recording, or displaying. Next, we'll discuss on signal conditioning and its necessity. The necessity of signal conditioning may be due to following reasons. Signals may be too noisy due to the electromagnetic interference. Signals may be too small, usually in millivolt range. Signals may be non-linear and requires to be converted into linear. Signals may be analog and requires to be converted into a digital form. Signal may be digital one and need to be converted into analog form. It may be required to improve the quality of digital signals. So due to these reasons, it is necessary that the signal to be conditioned. The process adopted in signal conditioning. The following steps are adopted in signal conditioning. The first step is the protection. The range of the output signals from transducer may be so high that may be damage the next unit or element which need to be protected. For example, if a high voltage or a current signal is fed to a microprocessor, it will get damaged. The microprocessor can be protected by employing a series of current limiting resistors and using a step down transformer if voltage is too high, or by using polarity protection, or by using a voltage limiting circuit, etc. The second step, getting right types of signals. The output signal of a transducer is of analog type. It needs to be converted to a digital voltage or current. Getting correct level of signals. The level of output signal may be too small. It needs to be amplified for feeding it into an analog to digital converter. It may also be difficult to measure such low signals. Elimination of interferences. Undesired signal or disturbances may be associated with the output signal which need to be eliminated. Such interferences are eliminated by using filters. Manipulation of signals. The output signal may be non-linear in nature. These need to be linearized and vice versa. Function of signal conditioning equipment. The signal conditioning equipment required to perform the following functions on the transducer signal. Amplification. The amplification must bring the level of transducer signal to the value suitable to convert, process, and record. Modification or modulation. Signal may be smoothened, linearized, filtered, or converted into digital form. Impedance matching. The signal conditioning equipment arranges the input and output impedances of the matching device so as to prevent loading of the transducer and to maintain the high signal level at the detector. Data processing. The measured data is processed into a mathematical operations to match the signal suitable to record. Data transmission. To transfer the signal from one location to other location without changing the content of the information. The task of signal conditioning requires the followings: ingenuity, proper selection of components, and faithful reproduction of signal. The elements of signal conditioning are designed in such a fashion as to be insensitive to all extraneous inputs. The accuracy range and dynamic response are all designed to be compatible with the detector transducer. In several situations, the signal conditioning or data acquisition equipment is an excitation or and amplification system for passive transducer. It may be an amplification system for active transducers. In both applications, the transducer output is brought to adequate level to make it useful for conversion, processing, indicating, and recording. In case of passive transducers, excitation is provided from the external source. The active transducer do not require excitation from external source. However, this signal have low voltage level and need to be amplified. The excitation sources may be DC voltage source or AC voltage source. Next, we'll discuss on DC signal conditioning system. Referring to the figure, the resistance transducer like strain gauges constitute one or more than one arm of a Wheatstone bridge, which is excited by the isolated DC source. The bridge can be balanced by potentiometer and can also be calibrated for unbalanced conditions. Characteristics of DC amplifier: it should have extremely good thermal and long-term stability. It may require balanced differential input giving high CMRR. CMRR is a measure of ratio of desired signal to undesired signal. This value should be high as possible. Advantages: the DC amplifier is easy to calibrate at low frequencies and can be easily recovered from the overload conditions. Disadvantages: the major disadvantage of DC amplifier is that it suffers from the problem of drift. As a result, the low frequency suspicious signals come out as data information. This problem is overcome by the use of drift amplifiers. The DC amplifier is followed by a low pass filter which eliminates high frequency components or noises from the data signal. Uses: DC systems are generally used for common resistance transducers such as potentiometers and resistance strain gauges. Next, we'll discuss on AC signal conditioning system. Referring to the figure, the problem encountered in DC systems are overcome through carrier type AC signal conditioning system. The transducer parameter variations, amplitude modulation, the carrier frequencies at the bridge output, and the waveform is amplified and demodulated. The demodulation is phase sensitive so that the polarity of DC output indicates the direction of the parameter change in the bridge output. In carrier system, it is very easy to obtain very high rejections of main frequency pickup. The active filters can be used as rejection this frequency and prevent the overloading of AC amplifiers. The carrier frequency component of the data signals are filtered out by the phase sensitive demodulators. Uses: AC systems are used for variable reluctance transducers, and for systems their signals have to be transmitted through long cables connected the transducers to the signal conditioning equipment. The physical quantities like pressure, temperature, acceleration, etc., after have been transduced into the analog electrical form and amplified to sufficient current or voltage levels, are further processed by the electronic circuit. In some applications, signals are directly applied to the indicating or recording or controlling instruments. In some applications, some signals need to be linear and non-linear operations on them. Amplification: an amplifier is a device which is used to increase the weak signal. It may operate on mechanical, optical, pneumatic, or hydraulic, electrical, and electronic principles. The gain of amplification is defined as the ratio of output signal I naught to the input signal II, G equal to I naught by I. The gain is dimensionless quantity. To get the greater amplification, two or more amplifiers are arranged in series or cascaded. The overall gain of the arrangement can be given by the equation, which is the overall gain of the cascaded amplifiers. Next, we'll discuss on types of amplifiers. On the basis of working principle, it may be categorized as mechanical amplifiers, fluid amplifiers, optical amplifiers, electrical and electronic amplifiers. In this video, we'll discuss on first three amplifiers. Next, electrical and electronic amplifiers will be discussed in other video. Mechanical amplifiers are further classified as simple and compound levers. The compound lever has two or more levers linked together so that the output of one lever provides the input to other. Simple and compound gears. Simple and compound gear arrangement are used quite frequently to provide mechanical amplification of either angular displacement or rotary speed. Compound gear arrangement gives a greater modification with the additional advantage of no change in the direction of the input signal. Limitations of mechanical amplifiers. Mechanical amplification usually suffers from the errors caused by the following factors: internal loading, elastic deformation, backlash, and fractures at the joining parts. Next, we'll discuss on fluid amplifiers and may be classified as follows. Hydraulic amplifier: when a small displacement is applied to a piston operating inside a cylinder containing some liquid, then occurs a large displacement of the liquid in the output tube, which has a small diameter. This principle is employed in the mercury in glass thermometer and the single column manometer. Pneumatic amplifiers, so they are extensively used and can be applied to any type of the measurement. Next, we'll discuss on optical amplifiers. In optical amplifiers, a ray of light strikes a mirror with an angle incident and gets reflected with the angle of reflection equal to the angle incidence. When the mirror rotates through an angle theta, the angle incident changes to I plus theta. Before rotation of mirror, the angle between the incident ray and the reflected ray is 2I, and after rotation it is 2I plus theta. There is an angular magnification of 2 theta between the incident and reflected rays. In order to get the greater amplification, more number of mirror surfaces may be used. This principle is used in optical levers, ultraviolet galvanometers, mechanical pointer galvanometers. Thank you for watching, and please like the video and don't forget to subscribe the channel.